Hello and welcome to EGM722, Week 2, Part 3, Errors and Debugging. So I figured I'd start this lesson with a universal truth, and that truth is that no matter what, when you are writing code, you will have errors. There's really no use trying to get around it. It's going to happen. It's better to just accept that it is going to happen, that you're going to have to deal with it, and we'll learn today about ways that we can deal with errors when they pop up. So, in Python, there are three main types of errors that we're going to need to deal with. The first are what are known as syntax errors, and these are produced when the interpreter is translating the code from the human-readable code that you have written into the machine-readable code that the computer will actually work with. The second are what are known as runtime errors or exceptions, and these are produced by the interpreter when something goes wrong while the program is actually running. The third kind of error that we'll talk about is a semantic error, and this is where no error message is produced, but the program doesn't quite do what we expected. Something isn't quite right, and we need to figure out what that is. And finally, debugging is just the process of identifying and fixing errors in the code. So, beginning with syntax errors. So there are some common messages that you will see when you have syntax errors in your code. Something like invalid syntax or cannot assign to something. So here we have three different errors. The first is that we're attempting to create a variable that has a name that doesn't follow the rules of naming variables that we discussed last week. Namely, we're starting with a number here, and that is not allowed, so we get a syntax error. The second one is that we can't actually have leading zeros when we're working with integer values, so we need to either delete these or use a specific prefix if we're using octal integers. We're not going to go too far into that. Just know that for the most part you can't have a leading zero when you're dealing with numbers. The last error here says that you cannot assign to literal. So what this is saying is that we have a literal or just an integer value here, and we're attempting to assign the string foo to that integer value, and that's not allowed. Python is not going to overwrite integer values with strings. We need to actually have a variable variable name that makes sense here. To try to work on debugging syntax errors, again, avoid Python keywords, make sure that you're following the rules for naming variables. Any headers that you write, so in function definitions, in for loops, while loops, in conditional statements, these should all end with a colon. If they do not end with a colon, it will raise a syntax error. Make sure that you go through and check your quotation marks, your parentheses, brackets, because if you have open quotation marks, open parentheses, open brackets that are not closed by a closing quotation mark, parentheses, bracket, etc., that will also raise a syntax error. And make sure to check your indentation, because if there are if you have an incorrect level of indentation in your code, that's going to raise a syntax error. Most of the time, the IDEs, the integrated development environments that you are using, are going to alert you to syntax errors before you even start running the code, but not always. So again, you might still deal with these and need to know what to look for. Runtime errors, again, are when the program passes all of the syntax checks, so it's syntactically correct, but it fails during execution. So we see an example here trying to call a method called scale on an object called a rectangle. And in the error message, you see that it says that the name length is not defined. And on the next slide, we'll talk about actually how to read this, this error message. So these, again, are also called exceptions. And there are some common causes that you will probably see. One of them is the wrong variable name. You see here the name error in this case, where we have tried to use a variable name that does not exist. It's not been defined yet. You might also see index or key errors when you're attempting to access items in a list or keys in a dictionary that have not actually been added to that list or dictionary. You might also see attribute errors where you're trying to access attributes for an object that have not been defined. So the traceback that we saw on the previous slide is how Python actually keeps track of function calls. So every time we call a function, Python keeps track of that function call as well as the functions that that function uses, as well as all of the functions that those functions use, and on and on. And the reason that it does this is so that if an error shows up, it can say exactly where that error started. This is something called a traceback. So when an exception is raised, that's what prints to the screen. And you can see here it says traceback, most recent call last. So we're reading from top to bottom in terms of the most recent to the original call where the error popped up. So this is going to provide the function, the line number, and the file name where the error occurred. In this case, because it's coming from the Python interpreter, the file is given as the standard input or the interpreter window at line 1, because it's the first line in this particular call. But then you see that it's happened in a file called shape.py at this very long path at line 18 in a method called scale. And then it prints the line where the error occurred as well as what the error actually was. So we're tracing all the way back through the sequence of function calls so that Python can tell us where it first happened and where we need to go to work on fixing it. So we can use this again to figure out where the error occurred and fix it. So the last type of error message that we will, or the last type of error that we will talk about is, again, something called a semantic error. And these are by far the hardest errors that we're going to have to debug because the program has run successfully. The interpreter has provided no error messages, but something isn't quite right. The program isn't doing something that we think it should be doing, or it's doing something that we think it shouldn't be doing. And the issue, ultimately, is that you did not write the program that you intended to write. So I've included a little joke here where your mom says that asks you to please go to the shop and buy a bottle of milk. If they have eggs, bring 6. You come back with 6 bottles of milk. Mom is upset. She says, why did you buy 6 bottles of milk? And you say, well, because they have eggs. Because the instructions that you were given were to, if they have eggs, buy 6 bottles of milk. So this is a joke, but this is often how computers actually work. They only follow the instructions that you give them, no more, no less. So we need to be very careful about the instructions that we provide. In order to debug these kinds of errors, we have to work backwards from the output. So here, because we have 6 bottles of milk, why did this happen? We go back to the original instructions to look at what happened to cause the output that we think was an error. So there are a number of different strategies that we have that we can use to try to debug these kinds of things. The first is to try to make our code a bit more readable. We can try to break complicated expressions into a series of variables that we can actually follow a little bit easier than trying to write out big, long, complicated equations. We can also, if we're not sure about the order of operations for a particular expression, we can use parentheses because it doesn't cost us anything, and it will ensure that we know the correct order that is being done on that expression. We can also use something called a debugger to help us pause the program at certain steps, look at the outputs, see if we can figure out where the output is going wrong. Most of the IDEs that you're going to find out there have debuggers built in, and you can look for your particular debugger, how you actually go about using that. When in doubt, take a step back, grab a soda, grab a snack, take a break, come back, try to look at it with fresh eyes, because a lot of times you get this sort of tunnel vision that just makes it very difficult to actually see the potential problem. I can't tell you how often it is that I've walked away from the screen for a little bit, come back, and immediately seen what the problem was. I recommend trying to do this when you're running into errors that are particularly difficult to fix. And if everything else fails, call Joe. And in this case, Joe is any person who can provide a fresh pair of eyes on the problem, because again, you will be amazed at how often you do not see something because of how close you are to the problem that someone else is going to pick up right away. So if you are able to call someone over or ask someone to have a look at your code, and they might be able to help you fix the problem. So to sum all of this up, you're going to have to deal with errors and or bugs. You're going to have to deal with errors and or bugs. It's just a thing that's going to happen. It's a very important part of learning programming, to learn how to correct errors and bugs. Different kinds of errors are going to require different kinds of troubleshooting. Debugging errors often requires a fresh look at the problem, either by you taking a break and coming back or bringing someone else in. But at the end of the day, you are going to have to learn how to deal with errors and bugs. That's all I have for this lesson. I hope you found it interesting and or useful. And if you have any questions, please don't hesitate to post them to the discussion forum on Blackboard. Thanks. Bye.